Okay, so we are doing factoring of quadratic expressions or equations today. Learning goals. So by the time you are finished with this video, you should be able to factor and solve a quadratic equation. Use factoring to arrive at a solution for a problem in a real-world context. And identify the correct use of factoring as well as identify the correct solution. So, when you are trying to find the zeros of an equation, so you're solving for x, the very first thing you should do before you do anything is see if you can factor it, because if not, you'll be forced to either use the quadratic formula or complete the square, which we get into next target. Factoring, so it's just like what it sounds. You use factors of numbers in order to solve this. You'll see kind of how this works in a second here. So, for example, take the equation x squared plus 11x plus 18 equals 0. We use a method of factoring. You draw an x, okay? And you're going to take the b and put it on top, and the c, and you put it on the bottom. All right, and if you need a reminder as to what b and c are, don't forget that your b is right there and your c is right there. And if I refer to a, that's the lead coefficient. So this right here, whatever number is in front of the x squared is your lead coefficient. Okay, so we'd put the 11 on top, the 18 on the bottom, and we'd move on to the next part, which is complete the sides by writing two numbers that are factors of the bottom number that add up to the top number. So we think about factors of 18, and we've got 18 and 1. 18 times 1 is 18, but 18 plus 1 does not equal 11, so that doesn't work. We'd try 9 and 2. 9 and 2, 9 times 2 equals 18, but 9 plus 2, it does equal 11. So we have our winner right there, 9 and 2, and we would write this as the variable in front of the numbers, so it would look like x plus 9 and x plus 2. Bear in mind that if you had a negative sign in front of one of those numbers, it would be x minus, not x plus. All right, so first example, we need to factor x squared plus 3x minus 18 equals 0. Same thing, draw your x. Next, b on top, c on the bottom. So 3 and negative 18. So notice I am including the sign to the left of it. Okay, you always do that for b and c and a. And so now we need factors of 18 again, but this time it's a negative 18. So you could be like, well, crap, because that doubles it, because I have negative 18 times 1, but then I could have a positive 18 times negative 1, and that's a long list. But notice that this 3 is positive. So there's no way that if we took away the signs that the larger number could get the negative sign and still get a positive answer when you add. So we know that it would be 18 times negative 1, if anything, but it's not, because you add those together, you don't equal 3. 9 times negative 2 still doesn't equal 3, but we're getting closer. 6 times negative 3, we have a winner now, because 6 and negative 3 do equal 0 and do multiply together to get negative 18. So there we go. All we have to do is put our variables in front. So we'd have x plus 6 times x minus 3 equals 0. Okay. Factor the expression and solve for x. Now, if you remember the special cases from last unit, this one will be a piece of cake, but I'm not going to spoil it for you. If you know it, then go ahead and try and guess the answer. But if you don't, you might be asking yourself, well, crud, because I need this in ax squared plus bx plus c, and there's no bx. There's nothing there. Well, that's very true. How do we write it when nothing's there? We put a 0 in front of it, because 0 times x would just be 0. Okay, doesn't change the problem, because that's 0 no matter what x is. So that's not going to change that, but we have a number to put in to our little x there, 0 and negative 121. Okay, when you have a 0 up top, that tells you that, and especially when this is negative, that tells you that this has to be a perfect square. Whatever number is here and here are going to be the same. One's going to be negative, one's going to be positive, at least if we're going to solve this by factoring. So assuming we are going to solve by factoring, which we are, we've got to figure out what 121 is a perfect square of, and it is a perfect square of 11. So we make a positive 11 and a negative 11. Okay, but notice it also said to solve for x. So we are going to set both of them equal to 0. And the reason we do that is because one of these has to be 0. We don't know necessarily which one, but at least one of them has to be 0, right? In order for this to be 0. So we set them both equal to 0. And then we're just going to solve for x, which means these x's stay put, these variables got to go, or not variables, these constants got to go bye-bye to the other side of the equation. So we subtract 11 from this one from both sides, add 11 to this one on both sides, and that gives you your answer. That's how we solve for x. Okay, next one. Same thing, except now you notice, wait a minute, our lead coefficient is 3. That's no bueno, and it's not. So ideally, what you're going to be able to do is factor that out of everything. And luckily, 3 does factor into everything. And when that happens, it's a beautiful thing, because then we can just take that out and we're left with something nice and pretty that we can use this with. Not that you can't use the x with the other way, but I will have to show you that in class. For now, let's focus on just being able to factor this out, because 3 goes into this once, into this 10 times, into 27 9 times. So that's where we get this. And then we go ahead and we put our b and our c there. We say, well, this one's easy. 9 times 1 is 9. 9 plus 1 is 10. Bam, done. Okay, we have x plus 9 times x plus 1 equals 0. We need to, again, set both equal to 0. Solve for x, so we're going to subtract 9 and subtract 1 from both sides of their respective equations. Your answers are going to be x is negative 9 or x is negative 1. Okay, fourth example. Rectangular lot is being turned into a community vegetable garden measuring 8 by 12. A path of uniform width is going to be around the garden in the area of the entire lot, so including the path is 140 meters squared. We need to write an equation. So keep in mind, the garden itself is 8 by 12. There is a uniform path. Okay, well, I know we did a problem where we subtracted an x, but this time we're adding a path. We're adding to the garden. Okay, the lot includes the garden plus this, so we're going to be adding. We're not going to be adding 1x because it goes around the entire garden, because here's 1x on one side, here's 1 on the other side. Same with the 12. There's an x on that side, an x on that side. So this is going to be 2x plus 8 and 2x plus 12. We know the area is 140, so this isn't set equal to 0. We set it equal to 140. Now we can't solve for it if it's not equal to 0. So what we need to do is we need to combine these. So we need to multiply these two out. So remember, first outer, inner, last. When you do that, you're going to get 4x squared plus 40x plus 96 equals 140. If you don't remember how I got from this step to this step, go watch the video before this one on multiplying polynomials. Okay, but hopefully you remember how to do this. It's still not 0 over here. We do that by subtracting 140 from both sides, which is going to give you 4x squared plus 40x minus 44 equals 0. Okay, we have that lead coefficient problem again, so luckily we can factor that 4 out of the entire thing, giving us 4 times x squared plus 10x minus 11, all equal to 0. So now we factor, as we have been this entire video. We have a negative 11 and a positive 10 that they need to add up to, which means our bigger number has to be positive, so 11 times negative 1, which gives us 4 times x plus 11 times x minus 1 equals 0. Which gives you x equals negative 11 and 1. However, there is a problem. We have a problem in a real-world context here, which means that all of our lengths, this x, the width of this path, has to be positive. We can't have a width of negative 11. That doesn't work. Okay, there's no way for that to work. So x actually only equals 1. You don't even have to include the meter. I did for the heck of it, but this is actually the correct answer. So in real-world problems, very often you are going to eliminate one of the answers because it doesn't make sense in a real-world context. Okay, final example. Sam and Lena solve the equation 2x squared minus x minus 6 equals 0. Who's right and how do you know? Well, rather than go through this whole thing, although you can pick up certain errors like this, no good. Okay. Lena is actually the one who correctly factored the quadratic, and if you take her answer, and this is how you can tell, you look at her answers. So if you take her answers and you substitute them back into the equation everywhere there's an x, you will get 0. Make sure you do it for both of them. Don't just check one of them, because one of them may work and the other one might not. So you need to check them both and make sure that they both equal 0. I suggest using a calculator for this. Or you can take the equation and plug it into a graphing utility and make sure that the x-intercepts are -3/2 and +2. Okay, that is all I have for you guys. Sorry about the longer video, but if you guys have any questions, ask them in the comments below, or find me if you are one of my students, and make sure you ask me in class. Take it easy.